Right, just going to have a little chat about nuclear fission. So starting point is to have a little bit of revision of radioactive material. We're starting here with an alpha particle. An alpha particle has 2 protons and 2 neutrons. So it's actually a helium nucleus, the atom helium nucleus. So it has a mass of 4, 1, 2, 3, 4, and 2 protons. And we can also write that as 4 mass 2 protons and then the alpha symbol. Beta particle is an electron, and we write that like this: no mass and a charge of -1. Again, it's a beta particle, so we could write no mass, charge of -1. Then gamma ray is energy, so we could write gamma, 0 mass, 0 charge. And then the fourth one that we're particularly interested in today is the neutron. So lowercase n, mass of 1 and no charge. So that is how we write a symbol for a neutron. Now let's say we've got a neutron. What can we do with it? Well, we can whiz it into another atom, bosh, and it will be absorbed by that atom. Doesn't do anything to it. The atom stays quite stable. It's quite small. It doesn't really make any difference to it. However, if we have a large nucleus, for example uranium atom, and we whiz a neutron into that, it becomes unstable and it splits into 2 smaller parts. In addition, it can fire out other neutrons, and they can collide with other nuclei, and if that happens we can get a chain reaction. Now let's just have a quick look at an animation of the fission. So there's the collision, and those particles are released and more neutrons are released. Now the important part here is that if that happens, we can end up with a chain reaction. So the original nucleus splits and neutrons are released, and those neutrons can collide with other nuclei and cause further splitting, and that carries on if that carries on in an uncontrolled way, what you will end up with is a nuclear explosion, which is the basis of nuclear weapons and nuclear bombs. So that's an uncontrolled chain reaction caused by nuclear fission. Now, the alternative is to control the reaction. So let's go back to this one, and what we've got is a boiler here, or nuclear reaction chamber, where the radioactive reaction, the nuclear fission reaction, heats up water, that turns into a gas and turns a turbine, which turns a generator. We want to focus on this area here. What happens in that area? Right, well what happens is you have nuclear material that is capable of fission, and between the rods of the reactor there are what we call control rods, which are these 3, and they're made of boron. A boron is a small atom, and it will absorb the neutrons. So the neutrons that are released by the reaction are absorbed by the boron, and so the chain reaction is controlled. It doesn't run out of control. Lift the boron rods out a little bit and the reaction goes faster, lower them back in and the reaction slows down. So that's how you control nuclear fission.